Hello, welcome back. We will carry on our presentation of overview of C. Today we start talking about executable statements, and then we provide you with a view of a general form of C program. So what are executable statements? The executable statement is a C statement that's used to write or code an algorithm. An algorithm is a set of steps that you are going to use or adopt to solve a specific problem. A C compiler translates this executable statement into machine language because computer can solve and can execute only machine language statements. Assignment statements. Most likely your algorithm that you are trying to design will consist of some assignment statements. Input-output operations. These input-output operations can be either directly from the user by interacting through the keyboard and the display or the screen, or could be used through files, or either through some IP addresses and internet protocols. Printf function. The printf is the main function that is called from the standard library sc.h that is used for printing and displaying results to the user. Scanf function. Scanf function is the main function from reading input from the users. Return statement. A return statement is a statement, as we have seen last time, that is indicating the end of a main function call or the end of any function that you are calling or designing in your C code. So during execution of a code, we have some memory assignments and we have some variables that are allocated into the memory. So we would like to monitor the progress of the content of these variables while the code is being executed step by step by the computer. So for example, we have some variables that are already there in machine language, and then we have some variables. We have variable called miles, we have a variable called KMS. These variables are of type double. They are assigned specific size in the memory, and then after some execution, these variables get some values. So the variables now, the update of variables, while the code is executing, as you can see, your content of the memory is changing and being updated. So things get deleted, things get stored, and things get updated. Assignment statement. So if you want to assign a variable after doing some arithmetic or some logical operation, you assign that variable to a specific operation, and finally you have to store the result in a specific variable which is already a placeholder in the memory. So for example, we are using the input of the user, which is stored in miles. We are multiplying that variable that was acquired from the user by the constant we have defined using the define statement, and then the result of this multiplication is stored in a variable which is already allocated in the memory called KMS. So as you can see the assignment statement above, we have just simply assigned a new value to the variable KMS. So if you look at the code execution, what's happening? We have some constant defined through the preprocessor command define. We have read some variable from the user. We stored it in miles. These two variables got fetched by the computer. They got multiplied. The result of this multiplication got stored in variable KMS. So after a while, at the beginning, the value of KMS was undefined or unknown. You could not know what's the content of that place in the memory. And after the assignment, it became 16.09. So we have the equal assignment. And remember, this equal assignment is the assignment operator. When you use equal, it will be used for different thing, and it has a meaning of equality test. So it has a logical meaning in that case. So we are reading it as follow. As it becomes, takes the value of, or equals. These are all assignments. And remember, as I mentioned before, the double equal is a test equality symbol in C programming. So you can write different assignment statements in your C code. You could have a variable that is called sum. You fetch the content of that variable. You add it to a content of variable called item. And the result of this operation, addition operation, will be again assigned to the variable sum. We will see later on how to make much abbreviated forms of this kind of operations, which assign the same variable on both sides of the assignment operation. So these are not algebraic assignments. We are not checking for equality. We are not doing a system of equation. We are simply assigning a result of some operation, arithmetic or logical, to a new variable storage. So the same thing, we look at variable of sum, we look at variable item, we get their content, we sum them. The result of the summation will be stored in a variable called sum. So as you can see, again, the memory gets updated once in a while in the memory. So input operation. So when you are transferring the input from the outside world to the computer memory, of course, the basic outside world is when you are reading some input from the user. So output operation now. So output operation, your program has made some arithmetic operations or some logical operations, or it has carried out an algorithm, and at the end of the day, you need to show the results to the outside world, to the user. You need to store the result in a file. You need to send this result over some internet or network connection. All this is kind of output operation that you are performing. So in between, all what you are doing is basically input-output operations. In some systems, like database systems, input-output operations are very heavy, and they could be really time-consuming, and it would be like the bottleneck of any execution code. Printf. So when you want to print something, when you want to do some output operation, you just simply call the printf functions, which is defined in std library. Scanf. If you want to input some input from the user, just call the scanf function with the proper arguments, and then you are doing some input operations. A function call. So as you have seen before, we have defined a main function. And inside the main function, we have been calling functions that are already defined in the standard array. So we are doing like kind of function calls. So calling a function means asking another piece of code to be executed and do some work for you. Printf function. So basically the printf function's structure is as follows. It has the printf name, the identifier. It has some string which are called the input arguments. So as you can see, this printf function here, it takes one argument, which is a string because it's between double quotes, and it's a comma, means it's another input argument, and the other input argument is called KMS. So basically this printf function is taking two inputs, a string input and another input. You will see other printf statements that take 3 inputs, other printf that take 4, that take 5, depending how many variables you want to print or to show to the outside world. So this is called formatting string, and then we have the placeholders, and then we have the printf list. Now, for example, if I want to explain this, that means we are printing this statement on the screen, that equals, and then there is placeholder here. That means some number will be put here. That number is a floating, and then there is a string kilometers. So the printf, it will know that it has to fetch the content of the variable KMS and store it in that placeholder. So when you print this on the screen, you will see, for example, if KMS is equal to 10, you will see that equals 10.0 kilometers. So now let's elaborate on the placeholder that are used in a printf function. The placeholders, they start with a symbol %. So we have different placeholders because we have different data types in C programming. So basically, there will be different placeholders for those data types. For illustration, we are providing the placeholder for the character, which is %C, for the int, which is %D, for the float, which is the %F, and for a double, which is %LF. As you can see, we use the %C for the character in either printing or scanning. Same thing goes for %D, same thing goes for the float. However, you have to be very careful when you are doing the scanf, because scanf, if you want to read a double format, you have really to use %LF, but the C programming language compiler is very lenient when it comes to printing, so even if you are using a double, it could be allowed for this one. Displaying the prompt. When you are interacting with the user, you should give him some information, what kind of data you are expecting from him as input. So we call this prompts. Prompts are used, of course, through the use of printf. So for example, here we are prompting the user to enter the distance in miles. So when the user, he will see on the screen a statement like enter the distance in miles, it will know that he's expected to enter a number that would mean miles. So he won't be entering a set of characters. He won't be entering a number which is negative, because we are talking about a distance or distance to traverse. That means it has to be a positive number. Scanf. So scanf, unlike printf, it's a function that is used for reading or acquiring the input. So it's called the input operation. So it has the same structure. It has the name or the identifier. It has some arguments. So the first argument, as it was with the printf, it was a string argument because it's becoming between double quotes. It has a placeholder, and then it has some name of variables where you are going to read. So in this example, whatever we are reading from the user is going to be read like a double value, and that value will be stored in a variable called miles. And please note the ampersand symbol here, which has meaning for pointer. So when you are entering some input, you have to store the variables, and that variables will be called miles. The placeholder, of course, as I said, is informing the compiler that we are going to read some input which is of double type. The ampersand it represents the address operator, which is expected because the scanf is expecting as a second input argument a pointer. So a pointer means address of a variable. So a pointer is an address variable. So if you pass only miles, that means you are passing a wrong argument. While it is expecting an address, so it has to be with ampersand. So let's see what will happen when we are doing some scanf operation in our code. For example, here we are showing a variable miles. So the variable miles, it was not defined before. So we declare the variable miles called double, and then we ask the user to enter some number. So the user, he typed on his keyboard 30.5. So now we fetch this number from the keyboard and we store it in the variable called miles, because we have been reading with %lf. That means we are reading this number as a double. Same thing if you are reading a string, if you are reading a character. By using the proper placeholder, you are going to get the same variables in the right order. For example, here we are reading a set of strings which are called Bob. The user entered on the keyboard, he typed B, capital O, small b, so Bob. So we start reading, so the first one will be stored in letter 1, the second one will be stored in variable letter 2, and third one will be stored in variable called letter 3. All the three variables are of type character. Finally, return statement. A return statement, as mentioned before, it indicates the end of the function, it indicates the end of the main, it indicates moving from a block of a code, as we see when we talk about repetition and selection structures. So we are transferring basically the control from one piece of code to another. When it comes to the main function, that means you are returning the control from your main function to the operating system. So return 0 means what? You are returning a 0 value to the operating system. In system programming, that means the code has executed properly and nothing is wrong, and you are handshaking with the OS and you are telling it everything is fine, and the proof for that is that we are returning a 0. So if the program returning some other values, you have to have a meaning of these values. For example, if you are returning -1 to the OS, maybe -1 in your OS means file not found, or maybe -2 means permission denied, and so forth. So it does mean that you are supposed to do something, but only it's just saying that you have done properly the code and you are exiting. So once you start writing your own function, you will use the same return statement to return values or to return the result of your computations to the calling function. It could be the main, it could be another function. So what is a general form of C program? So as we have seen before, we have pre-processing directives, include statements, define statements, we have the main function heading, we have declaration of variables inside the main, and we have executable statements. Executable statements could be statements that you are writing yourself, or could be function calls to other functions that are either in the standard library or functions that you have written yourself. Comments. So a comment is a form of documentation. It won't be read by the C compiler, it will be ignored by the compiler, but it's meant for the programmer. Sometimes you want to remind yourself about the purpose of the code you are writing. Sometimes your statement could be so tricky and complicated that if you look at them after 1 week, it will be very hard to understand what they do. So writing simple comments aside of these lines, it could give you much more information about what's the purpose of your code you have just written a week ago. So we have two formats, which are called the C comments. So it's one line, so it's a slash, star, and then you put some text or documentation or comment, and then you enclose it with star, slash. Or you have double slashes. This is called the C++ comment. And then of course, you are using it to create program documentation. Of course, as you will learn when you progress in programming field, you will know that software documentation or code documentation is a crucial part of any successful code development. So information that will help others to understand what's happening in your code. So you should make comments that are meaningful. You should make comments on the function purpose, the expected input, the expected output, and so on. Programming styles. So do we have to follow conventions when you are writing programming styles? Yes, because these programming conventions, they are not compulsory, but they will lead to a neat and clean and easily readable and easily understandable code that you are going to write and to allow other people to understand. So it has good readability. People could read it easily. A code that people could read easily, that means they could understand easily. A code they could understand easily, that they could maintain easily, that they could improve easily, and that's very crucial for any software development. So 80% of the lifetime of software you are spending in developing and fixing and maintaining and updating and removing the bugs and fixing some problems in the code. So it's huge. So if you write a neat code, if you have readability, that means this effort in maintaining the code will be much, much less. So you cannot document your code and write it and do debugging and do maintaining. Someone will write a code, you will do documentation, someone else will do the maintenance. You will do the comment, someone else will write the code, you will do the implementation, and so on. So always check your textbook because it has more information about programming styles and methodologies. White spaces. Of course, these white spaces are completely ignored by the compiler. So you could put as many white spaces as you want. But keep in mind, you put white spaces as needed because it might affect the readability of the code. So leave a space assignment so you could read between the lines what's happening. Bad example of a code. So you could put everything together clumsy like this. Or it could be with spaces, as you can see, you compare here, the assignment statement, you are getting the value of foo plus 1, you are assigning to blah, and here the same thing. And look how clear and readable is this statement compared to this statement. Or because of putting some white spaces between the variables. So white spaces, they are not costly, they don't cost you anything. Putting too much of them, abusing them is not recommended, but also not using them could lead to a very, very hard to read code. Other styles. You do some documentation. Write comments, even if you are the only person who's going to read the code after a while. Write comment for yourself. Give variables meaningful names. You have a variable that has to store miles, don't call it X, call it miles. You are calling a variable to store an ID of students, call it ID, don't call it Y, and so on. So make a prompt for the user. When you are asking and doing some input operation, you don't expect the user to understand all what you are going to ask him. So write a good prompt statement, very clear good prompt statement so the user can understand what is expected from him so he can get you the right input. Because remember, if you get garbage in input, basically your code will produce garbage. So insert new lines, put commentation, put comments, make white spaces, format the numbers. All these kind of things, they give a meaning to your variables, to your code, and finally execution will be peaceful. Bad programming practices. Yes, you could end up in very bad programming practices. You could miss the statement of purpose. For example, nobody knows what is the purpose of the code because some documentation is missing. So people have to read thousands of lines to understand maybe your code is doing a simple input-output formatting. You put wrong comments. Sometimes comment could be misleading. The main purpose of comment is to make things easier, not to make things much more confusing. Variable names that are not meaningful. People could name variable names. So basically, the bad programming practices are all kind of opposite recommendations that are proposing for good programming habits. Using of unnamed constant. You could use a name of constant which has no meaning. Indentation. You don't indent the code. You don't put proper indentation when you are in a code blocks. This could be really affecting your readability. Algorithm is inefficient. You could write an algorithm. For example, if you have thought about a code solution, you could have written it with one loop instead of writing two nested loops. Program doesn't compile. Some bugs are there. You are missing some library functions. You are misspelling some function code. All this could affect your things. You could get into bad results, wrong results. For example, when you are doing some equality test, remember, we were using double equality sign. If you put one equality sign, that means you're talking about assignment. And in this case, the compiler will go silent about this, and then you end up in a big and serious bug in your code. So you don't do testing. You don't test all the cases. For example, you are reading some inputs, and you are always assuming that the user will give you the valid input. Make sure that you get enough testing and enough input validation in your code.